All right, take 3. I've tried to record this 3 times and twice it's crashed, so let's hope that the 3rd time is a charm. Today we're going to look at angles of elevation and depression and how we can use them for trig. First, you got to know what an angle of elevation is, and you got to know what an angle of depression is. And once you know that, we're going to use that to solve problems. So what is an angle of elevation? An angle of elevation is when you're looking up at something. So this little stick figure here is looking up at that space shuttle, maybe? I don't know. Okay. And that line, angle of elevation, is from a horizontal line, whether it's the ground or whether it's a horizontal line from your eye level like it is here, and what you see looking up. So this is your angle of elevation. The angle of depression is when we're looking down. So you've got that horizontal again, okay, and we're looking down. That is our angle of depression. The horizontal line, or that horizontal line, is parallel to the ground. So if I was just to kind of draw this picture out with the little guy on the cliff and the whale or whatever he is watching down there, okay, this is my angle of depression. This is my angle of elevation. Since we've made these either the ground or horizontal to the ground, that means that I've got parallel lines, okay? And these angles are alternate interior angles, so they're congruent. It's going to be a key point because we have to really decide if we're using depression or if we're using elevation. If you draw and make your right triangle like this to the ground instead of the way they have it in this drawing, know that this angle right here is not the angle of depression. That angle is 90 minus the angle of depression. Because if we've made parallel lines, remember that this is a right angle then, because this angle is right. So you need to be careful when you're solving problems. Okay. Angle 1, we're looking down, the man to the boat. We're looking down, it's depression. Angle 2, that one right there, the man in the boat is looking up to the man of the cliff, who is elevated above him, so it's angle of elevation. Angle 3, we're looking down to, I don't know, the scuba diver or whatever that is there. It's depression. Angle 4, the diver is looking up to the boat, so that's elevation. So remember, if you're looking up, it's elevation. If you're looking down, it's depression. All right, so let's look at an example. I have a child standing across the street from his apartment. And so here's the apartment building, and I want to see drawings on all of your homework if there isn't one already there. Okay, so here's my child, and his mom is on the balcony. And it says that the angle of elevation between the mom's eyes and the child's eyes, or the child's eyes and the mom's eye, is 22 degrees. So it's right here. So the ground makes a right triangle with the building. And if the distance between their eyes is 32 feet, so mom's eyes are at the top of the triangle, child's eyes are at the bottom. So this is where your 32 feet is, your hypotenuse. We want to know how far the child is standing from the apartment building. So we're looking for this. Sometimes we call that the horizontal distance or the ground distance. So in this case, I have the adjacent and the hypotenuse, okay? So that is going to be cosine. So this is the cosine 22 equals the adjacent, which is x, over the hypotenuse of 32. So x, using the symmetric property, turn this around, is equal to 32 cosine 22. We need to multiply both sides by 32 to get x by itself. And when you do that and plug that in your handy dandy graphing utility, x is going to be approximately 29.7 degrees, but we are asked to round to the nearest foot. So in this case, the child is 30 feet from the apartment building. Okay, take a second to read that. I got some woman looking down from a hot air balloon. So here's our hot air balloon. Right here. Call that the balloon. And I've got a sheep down here. I would draw it, but I'm really bad and I'm using my finger anyways. And the angle of depression from the balloon to the sheep is 35 degrees. And if the sheep is 125 feet from where the woman is looking down, so the woman's looking down from here, he's 125 feet basically above the ground, and we're looking for this distance. Okay. Now, that angle of depression, okay, is not inside our triangle, but this angle is 90 minus 35, which is 55. Okay. Or we could use the fact that they're parallel, and this would be 35. So you can use either. If I use the tangent of 55, I've got the tangent of 55 equals the opposite over the adjacent 125. So I get 125 tangent 55 equals x. And when I put that into my calculator, I get approximately 87.53 or 88 feet. Now I've looked at one more example. Okay, now I've got an angle of elevation E from A to B, and the angle of depression D from B to A are given. So here is my triangle, or my A to B. My angle of depression is 2 times x plus 2. My angle of elevation is 3x minus 16. Remember that these are made with horizontal to the ground lines. So these are congruent. So I'm going to distribute. I'm going to get 2x plus 4 equals 3x minus 16. Setting them equal to each other because they're congruent, I'm going to subtract 2x from both sides. So I get 4 equals x minus 16. If I add 16 to both sides, I get 20 equals x. And I'm looking for the angle measurement. They're going to be the same, so I just need to find one. So 2 times 20 plus 2, or 2 times 22, is 44 degrees. So that angle measure is 44 degrees. So I'm hoping against all hope that once I push stop, it won't crash. Let's have a math-tastic day.